So students, in this video we are going to discuss all the important JEE questions for complex numbers from class 11. So watch the video till the end. Example 1. For a complex number z, if real part of z minus 2i upon z plus 2i is 0, find the maximum value of mod of z minus 6 plus 8i. Consider z is equal to complex number a plus ib. Then z minus 2i upon z plus 2i. We first simplify that. So it is a plus I into b minus 2 upon a plus I into b plus 2. Now to rationalize the denominator, we multiply by the conjugate a minus I into b plus 2. So the real part of z minus 2i upon z plus 2i, after simplification, we get that equal to a square plus b square minus 4 upon a square plus b plus 2 whole square. And this is given equal to 0. So now, if this is equal to 0, we know that a square plus b square minus 4 will be equal to 0. So a square plus b square will be equal to 4. What is a square plus b square? By formula of mod z, this is equal to mod z square. So we have mod z square is equal to 4 or mod z is equal to 2. But mod of z1 plus z2 is less than or equal to mod z1 plus mod z2. Remember, this is a triangular inequality which we often use in the examples of this type. So now consider your z1 as z and z2 as 6 plus 8i. So what do we want? We want z minus 6 plus 8i. So now this is less than or equal to mod z plus mod of 6 plus 8i. Now mod z is 2. We have already obtained that. And what is mod of 6 plus 8i? Root of a square plus b square means root of 36 plus 64. So on simplification, this is equal to 12. So the maximum value for mod of z minus 6 plus 8i is equal to 12. Example 2. Now this is again a different type of example. If the set R consists of ordered pairs of the type AB such that A plus 5B is equal to 42, A, B are natural numbers, has m elements and sigma n running from 1 to m, 1 minus I raised to n factorial is equal to x plus iy, where obviously I is root of minus 1, then find the value of m plus x plus y. Now see over here, we are given a set R which consists of ordered pairs and fulfills the condition A plus 5B is equal to 42. But remember, A and B are natural numbers, means 1, 2, 3, 4 and so on. So now suppose if we start with A is equal to 1, then if A is equal to 1, 5B is 41, B is 41 by 5. But that does not belong to n. So it will not be included. Then we take A is equal to 2. So 5B is 40. So B is 8. So this is one of the ordered pairs. In this way, we go up till the value 37. If A is 37, then B will be equal to 1. But after that, we will get B negative. So again, not a natural number. So these are the only possible ordered pairs in the set R. And the number of elements is denoted by m. So m is equal to 8. 8 elements in R, so m is 8. So first thing is we have obtained m. Now it is given sigma n running from 1 to m means sigma n running from 1 to 8. 1 minus I raised to n factorial. We simplify this. So first term is sigma 1. See, always remember sigma 1 is n. That means whatever maximum value n takes. So that is equal to 8 over here. So sigma 1 is n, that is equal to 8. Minus, it will be I raised to n factorial, means I raised to 1 factorial plus I raised to 2 factorial up till I raised to 8 factorial. So I raised to 1 plus I raised to 2, 3 factorial is 6, so I raised to 6. Now after that 4 factorial means 4 into 3 into 2 into 1. So 4 is multiplied by some integer. Same way 5 factorial is 5 into 4 into again 3 into 2 into 1. So after 3 factorial, starting from 4 factorial up to 8 factorial, all are multiples of 4. So I raised to 4k is 1. So we directly put that equal to 1. So now you have I square is minus 1, I raised to 6 is I raised to 4k plus 2 times. So again it is minus 1. So putting these values and simplifying, we get 8 minus 3, which is 5 minus I. Now this is equal to a complex number x plus iy. So here x is 5 and y is minus 1. So now we have m, x and y. Putting the values, we have m plus x plus y is equal to 12. So 12 is the answer. Example 3. If z is a complex number such that mod z less than or equal to 1, then the minimum value of mod of z plus half into 3 plus 4i is what? Now it is given over here mod z is less than or equal to 1. Again, by the triangular inequality, we have mod of z1 minus z2 greater than or equal to mod of mod z1 minus mod z2. So now over here take z1 as z and z2 as minus half into 3 plus 4i. So we can use the given inequality mod of z1 minus z2. So that is greater than or equal to, left hand side is greater than or equal to mod z minus mod of minus 1.5 minus 2i. Now mod z less than or equal to 1 is given to us, and mod of minus 1.5 minus 2i, you take out minus, it is 1.5 plus 2i. So you know mod is given by root of a square plus b square. So 1.5 square plus 2 square, which is equal to root of 6.25 or 2.5. So we have got that left hand side is greater than or equal to 1 minus mod of 1 minus 2.5, which is 1.5, because mod means it is always positive, so it is 1.5. So the minimum value is 1.5, or you can say 3 by 2. Example 4. Let z1 and z2 be two complex numbers such that z1 plus z2 is equal to 5 and z1 cube plus z2 cube is equal to 20 plus 15i. Then find the value of mod of z1 raised to 4 plus z2 raised to 4. Now see what is given to over here. We have seen examples of this type for real numbers. Similarly, this is for complex numbers. z1 plus z2 whole square will be equal to 25 because it is given z1 plus z2 is 5. Now what is that? z1 plus z2 whole square is z1 square plus z2 square plus 2 z1 z2, which is equal to 25. Or you can say z1 square plus z2 square is equal to 25 minus 2 z1 z2. Now next thing which is given is z1 cube plus z2 cube, that is equal to 20 plus 59. But a cube plus b cube formula, using that we get this equal to z1 plus z2 into z1 square plus z2 square minus z1 z2. Now we have the value of z1 square plus z2 square, 25 minus 2 z1 z2, which we put over here. So after simplification, what we get over here is 25 minus 3 z1 z2 is equal to 4 plus 3i, because we take out 5 common. So what we have is 25 minus 3 z1 z2 is equal to 4 plus 3i. So 3 z1 z2 is equal to 21 minus 3i, or z1 z2 is equal to 7 minus I. So from these two things which are given to us, we have found the value of z1 into z2, which is equal to 7 minus I. This value we are going to use to simplify z1 raised to 4 plus z2 raised to 4. For obtaining that, what is z1 square plus z2 square now? We have just seen in the starting that z1 square plus z2 square is 25 minus 2 into z1 z2. Putting the values, this is equal to 11 plus 2i. Now what is z1 square plus z2 square whole square? It will be 11 plus 2i whole square. So when you simplify this, it is 11 square 121 plus 4i square, put I square as minus 1, plus 44i. So this is equal to 117 plus 44i. What we want is z1 raised to 4 plus z2 raised to 4. This is equal to 117 plus 44i minus 2 z1 square z2 square. Correct? So this is equal to 117 plus 44i minus 2 into we have the value of z1, z2, just square it. So it is 2 into 7 minus I whole square. Now z1 raised to 4 plus z2 raised to 4 after simplification will become 21 plus 72i, correct? Because you put I square as minus 1. So now mod of z1 raised to 4 plus z2 raised to 4 is equal to, how do you get the value of mod z? Root of a square plus b square. So a is 21 over here, b is 72. The root of 21 square plus 72 square, which is equal to root of 5625 or 75. So the answer mod of z1 raised to 4 plus z2 raised to 4 is equal to 75. Now, like the example we just did, many examples of this kind are asked. One of them is given over here. So solve it as an assignment example. If z is equal to 2 plus 3i, then find the value of z raised to 5 plus z bar raised to 5. Remember, if z is a plus ib, what is z bar? A minus ib. So you have to simplify and find the value of z raised to 5 plus z bar raised to 5. And the answer is 244. Example 5. If 1 plus I upon 1 minus I raised to m by 2 is equal to 1 plus I upon 1 minus I raised to n by 2, both of them are equal to 1, m and n are natural numbers, then find the GCD or the greatest common divisor of the least values of m and n. Now first thing is, whenever you see this type of example, we try to rationalize it by multiplying and dividing by the denominator, by the conjugate. So we multiply and divide by 1 plus I. So the numerator will be 1 plus I square, denominator will be 1 square minus I square, or that is 2. So same way we do for m and n. So what do we have? 1 plus I whole square raised to m by 2 upon 2 square raised to m by 2. Similarly, 1 plus I square raised to n by 3 upon 2 square raised to n by 3. Both are equal to 1. It is given. So what do we get? 1 plus I square by 2 whole raised to m by 2. And 1 plus I square by 2 whole raised to n by 3. Both of them are equal to 1. Now, thus what do we have? What is what is this? It is I raised to m by 2, which is equal to 1, and I raised to n by 3, which is equal to 1. Why? Because it is given over here. Just try to simplify. 1 plus I square by 2. It is 1 plus I square is 1 plus I square plus 2. I put I square minus 1. So you get that equal to I. So ultimately what we have obtained is I raised to m by 2 is equal to 1 and I raised to n by 3 equal to 1. Continuing with the example, we know that I raised to 4k is equal to 1 for any integer k. So m by 2 will be, since I raised to m by 2 is 1, that means m by 2 has to be some 4k1 type, where k1 is any integer. Same way I raised to n by 3 is 1. So n by 3 has to be of the type 4k2 for some k2. So now over here, what will be your m? M will be equal to 4 into 2k1 means 8k1, and n will be equal to 4 into 3 means 12k2. So the least values, now remember over here, the least values of m and n will be what? 8 and 12. Least possible values will be 8 and 12. So the GCD of 8 and 12, we know it is equal to 4. And why have we taken 8 and 12? Because remember, m and n are natural numbers, so obviously negative is not possible. So now GCD of 8 and 12 is 4. So the answer is 4. Next, example 6. Let the minimum value V0 of V. What is V? V is equal to mod z square plus mod of z minus 3 square plus mod of z minus 6i square. Z belongs to C. If the minimum value is obtained at z is equal to z0, then find the value of mod of 2z0 square minus z0 bar cube plus 3 whole square plus v0 square. Now, first of all, z is any complex number. So suppose z is a complex number of the form a plus bi. Then what will be z minus 3? It will be a minus 3 plus b into I. We are just taking out the real and imaginary part different. Same way z minus 6i will be a plus bi minus 6i, means I into b minus 6. So now what is given to us, left hand side we'll try to simplify. First term is mod z square. Z is a plus bi. So what is mod z? It is mod z is root of a square plus b square, and mod z square is a square plus b square. Second term is mod of z minus 3 whole square. Z minus 3 mod of z minus 3 whole square means it is again the real part square plus the imaginary part square, means a minus 3 square plus b square. And same way z minus 6i mod of z minus 6i square means a square plus b minus 6 square. Now we just try to simplify this. After simplification, taking out 3 common, what do we get? 3 into bracket a minus 1 whole square plus b minus 2 whole square plus 10. Why are we doing this? Because we have the terms 2a and 4b. So now this you can write it as 3 into a minus 1 whole square plus b minus 2 whole square plus 10. Now we are given that the minimum value of V0 is obtained at Z0. So from the above equation what we have is A is equal to 1 and B is equal to 2. By putting these values we will get the minimum value. Correct? The minimum value we will get by putting A, because A minus 1 whole square and B minus 2 whole square. So by putting A is equal to 1 and B is equal to 2 we will get the minimum value. And what will be that minimum value? At A is equal to 1, B is equal to 2, V0 or the minimum value of V will be 3 into 0 plus 10 means 30. So we have got two things over here. We have got Z0 as the complex number 1 plus 2i. Why? Because A is 1 and B is 2. And we have got V0 as 30. That means the minimum value V0 is equal to 30. Now continuing with the example, what we have obtained, Z0 is the point 1 plus 2i and V0 minimum value is 30. So we try to simplify the left hand side. 2 into Z0 square minus Z0 cube plus 3 whole square plus V0 square. Use the formula for A minus B whole cube. So after simplification, what you get is mod of 8 plus 6i square plus 900. What is mod z? Mod z is again root of a square plus b square. So a mod of 8 plus 6i whole square is 64 plus 36. 8 square plus 6 square plus 900. So ultimately our answer is 1000. In the previous video we had seen the concepts and related examples on complex numbers. In this video we have seen the JEE questions asked from the chapter Complex Numbers class 11. So do like and share the video and subscribe to Maths Practice.